company that makes Granos is great too. That's what it would be like. That's what it would be like, okay? For Biden to give a shout out to artificial intelligence. That's how ridiculous it is. And I hope you understand the gravity of it. Anyway, the point of this is for me to explain to you why it's so ridiculous that in every, again, commercials are one thing. We're inundated with commercials in every media outlet in this country. Commercials everywhere. They're stifling. And that's a whole issue in itself. Okay? But it's the fact that these tech companies have been able to use AI to penetrate into what is supposed to be non-business type things like the federal government, non-profit things. And they've been able to convince, Congress and not everybody, I'm not saying everybody, but most people, okay? They've been able to convince most people in areas that they should remain completely neutral, that AI is this new amazing thing. Okay? And it's not. It's not new and it's not amazing. So, anyway, let's get back to the basic computer science 101. So, the telegraph, all right, and then computers over the years started getting more sophisticated. And key is they started getting smaller. You had the phone, okay, the telephone, okay, and then some of the early computers. And let's say 70s, 80s, when you first started having the basic desk, think Pong, think the Apple IIe, your basic desktop computer. It has a screen, it has a keyboard, okay? What a computer is, okay, it's an electrical system, kind of like the telegraph. It's an electrical system in which a user puts an input in. The electricity that input goes through, like the keyboard, goes into the computer, into the microchip and hard drive, where it is greeted with a code. That code is then programmed to give you an output on the screen. So the basic reality of it is, when I push a key, a screen has a number of pixels. Let's say the screen we'll start out with 1 pixel. The computer is programmed that when I push that one button, the pixel turns on. So you get an icon of light. Alright? So you're looking at your monitor, you get an icon of light. Push the button, the icon of light comes up. That's the electricity going through the computer and on your screen. When you let off, the icon turns off. So what you have then is a 1 that corresponds with the pressing of the button and the icon turning on, and a 0 which corresponds with the icon turning off. Okay? So you have a 1 0 1 0 1 0 1 1 1 0 0 0. In math, they call it binary, or the language of computers. And again, all it corresponds to is a 1 is on, and a 0 is off. So every time I touch an input on the keyboard or mouse or a click or whatever, the computer is telling the screen to turn on or off. Now let's go one step more complex. Now instead of a screen that is just a single pixel or icon, now we have a screen that's a grid. And let's say that this grid has 100 pixels. So now we have a screen that has 100 pixels. Now, each one of those 100 pixels, we can decide if we want to turn on or off. So, a keyboard doesn't have usually 100 keys. All right, usually it has an alphabet, which is 26 characters and numbers, okay, 0 through 9. And usually what happens is, okay, so remember we have a screen that has a grid of 100 pixels. The computer then is set up so that for whatever you happen to push, let's say now you have a keyboard as well, you have the letter A. You push A, that grid on the computer is programmed so that it'll turn on in the shape of an A. So your grid has pixels light up. Maybe they're 50. So most of the pixels are off, but then, 20 of the pixels in the shape of an A. So when you push an A, it lights up the pixels on the screen in the shape of an A. Okay? On or off. That's it. That's the basis of computer science. And maybe right now you're like, it's more complex. Yeah, it is more complex than that. Why? Because what we've done is we've taken increasingly numerous pixels in screens. Okay, that's the number one big thing. Okay, so instead of 1,000 pixels, I have, hundreds of thousands of pixels. Some of the new TVs, I think, have the OLEDs and stuff have, I think, hundreds of thousands of pixels. I'd have to look into that. But there are an incredible number of pixels. But each one of those pixels corresponds to a basic command of on or off. Okay? On or off. Is electricity going to that pixel and turning that pixel on or off? Now, of course, they have color, okay? And by the same token, what you have are processors that tell the screen, okay, now am I going to turn it not only on or off, but is it going to be red? Is it going to be indigo? Is it going to be, black? All those things, okay? But at its core, it's still that basic binary language of on or off. When I put in an input, am I turning that pixel on or off? That's it. There is no thought process involved. This is an electrical signal coming from your outlet, going to your input device, like a keyboard, a mouse, or remote control, going through the circuit board in the computer, and then going to your output device, a TV, a monitor screen, and telling that pixel to turn on or off, red, blue, yellow, white, whatever. But it's based in electricity. And it's just an on or off. That's computer science at its core. That's what a computer is. Okay? Now, over time, they've gotten how they've gotten more sophisticated is, like I already mentioned, the number of pixels on the monitor, the number of colors, and the size of the microchip. Okay? The size of the microchip has is probably the biggest thing that has made computers more and more sophisticated. And what they've done, I'm sure you've heard of semiconductors. All a semiconductor is it's a board of circuits in which, instead of a crude piece of wire, okay, like the telegraph, all right, and like Morse code, instead of a crude big piece of wire, they are literally microns thick wires. Those microns thick wires are embedded on top of that semiconductor board, okay, and all that means is that the board itself does not conduct electricity, okay? So you can embed it using gold, usually gold, because it's such a good conductor, but you can make a wire microns thick. And now when you can make a wire microns thick, now you can put millions of different lines on that circuit board, on that semiconductor. So now